Hey folks, how's it going? It's Mr. Murray coming to you with a do now for Wednesday, April 29th, 2020 for Course 1 Honors. So happy you're joining me here, and I've got a little bit more practice for us to do together. So what I want you to do is I want you to solve the equation negative 4k squared minus 31 is 33, and then I want you to write the explicit and recursive rule for 3, negative 12, 48, negative 192, and negative 200, 100, negative 50, 25. So please take a moment, pause the video, attempt these problems, and then when you're ready, unpause, and you can see what I got. Okay, so moving on down, start with this. So 4k squared, negative 4k squared minus 31 is 33. So first step here, this is one where first I'm going to try to think about this one. So look, the idea is we have two methods here, factoring and square roots. Now, I'll be straightforward and tell you both of those methods could potentially work here. In theory, if you think about it, we could potentially see if we could move the 33 over and see if we have a difference of squares, or we could use square roots because there's no b value. So that's telling me, if you look on the left, there's no something k or negative something k. So what that tells me is the square roots method is a possibility. Now, for me, it's going to be easier to move the 31 over, so I'm going to add the 31. And I would argue that if you can use square roots, it's generally going to be a little bit easier or quicker, I guess, to get to the answer. So I get negative 4k squared is 64. So I divide both sides by 4, or I guess by negative 4. And I get k squared is negative 16, right? You can verify 64 divided by 4 is 16. Now, k squared is negative 16. What number multiplies by itself to get negative 16? There are no real solutions. K is not a real number. There are no real solutions. So if you write k is not an r, that would be 100% correct. That is true. That means k is not a real number. You could write no real solutions. That's correct. Or k equals plus or minus the square root of negative 16. Now, the square root of negative 16 is negative 1 times 16. So the square root of negative 16 is the square root of negative 1 times the square root of 16. And the square root of 16 is 4. And we talked about earlier how the square root of negative 1 is I. So it's plus or minus 4i. Okay, now if you don't include the I, it will be perfectly fine this year, but next year you are going to have to start being able to state the imaginary solutions. So again, if you want to write them now, that's fine. If you want to write no real solutions, that's fine. If you want to write k is not a real number with a little e with a line, that's fine. Any one of these three things in course 1 honors is acceptable to me. Okay, now moving on down, we need to find the explicit and the recursive rules. So the two things we need to know are that our ratio is negative 4. 3 times negative 4 is negative 12. Negative 12 times negative 4 is 48, etc. And the first term is 3. So let's start with the explicit rule. I know that we're going to have something like this. So there's some a value we don't have, but we need. And then that's going to be multiplied times negative 4 to the power of n. It's going to be something of this form. I know that these are the n values here. So you plug in 1, you get 3. You plug in 2, you get negative 12. You plug in 3, you get 48. You plug in 4, you get negative 192. So let's say that I plug in 1. My rule needs to make sure that 3 is what comes out, because that is the sequence that I have. So if I do negative 4 to the power of 1, I get a times negative 4. And then how do I get a alone, right? I'm just trying to get a alone. I divide by negative 4. So I get a is equal to negative 3 over 4. Okay? So again, the negative 4 comes from the fact that as I go from left to right, I'm multiplying by negative 4 over and over. And this exponent means to multiply over and over. And by changing what n is, I change the number of times that I'm doing that. Okay? The a, by making it negative 3/4, ensures that when I plug in 1, what comes out is negative 3/4. And once I get negative 1 correct, then the rest of the terms will follow because it's consistently being multiplied by the same number. So my final explicit rule is f of n equals negative 3/4 times negative 4 to the n. Now, some teachers are going to teach this little n-1 trick. Here's why I don't teach that rule. One, if you don't remember the rule, it's useless. Sorry to be blunt, sorry to kind of put anyone down there, but that's the thing with rules. If you don't memorize them, if you don't know them, what good are they? Okay? And I find a lot of people struggle to remember the rules. The other reason is because going forward, what this is hitting on is we're talking about an exponential function. This is a function where you plug into the exponent. It's exponential. So the thing is that when you plug into an exponential function, right, you want to and get an answer, right? Well, that's going to come up when we talk about these functions. That's where we're going with this. And so I might ask you, hey, I know that this is how much it's going up by. And I know that maybe 3 seconds after we started, there are 10,000 things. What's the function? So that way of making a model is the exact same way we create a model here. So by understanding what's going on here, we're learning skills that are helping us model sequences and then later helping us model exponential phenomena. So I'm trying to teach you one skill that works in 2 places rather than a skill that works here and a skill that works there. They only work in 1 place each. I'd rather have you do more with less than less with more. Okay? If other teachers want to teach the n-1, that's totally their decision, and I completely respect that. So, recursive. First, we say the first term, and then, so the sequence begins at 3. The first term is 3. Every other term is the term right before it times negative 4. Okay? And remember, in any recursive rule, this piece, well, not the 3. Let me just back that out. This piece and this piece in red, those are always the same. You always have to state the first term, and you always have to declare, like, to get every other term, it's equal to the last term. You always have to say this stuff in every recursive rule. It's just that not every recursive rule starts at 3, and not every recursive rule you're multiplying by negative 4. That's not how every sequence is, right? So things to think about. Okay. All right, and now just take another look at this. As it turns out, a student pointed out that I had made a mistake here. So I'm actually making a correction. And so my hope is that I will upload the fixed video. And so now you can see what the right answer was. So if you take a look at the sequence, negative 200, 100, etc., you see that it's going down by a half. First of all, the numbers are negative, positive, negative, positive. So we know it's a negative because the negative makes the signs flip. So it goes from positive to negative to positive to negative, or negative, positive, negative, positive. All right, that's the effect of having the negative there. Now the numbers themselves are getting cut in half. So r is equal to negative a half, and the first term is equal to negative 200. Okay, so for the explicit rule, the first thing we do is we take a look and we say, okay, f of n is equal to a times negative 1/2 to the n, because remember the general rule here is a times r to the n. All right, and now remember, when we plug in 1, we have to get 200 because the first term, or rather negative 200, because the first term is negative 200. Okay, and now we know anything to the power of 1 is itself. And then to cancel, we multiply by negative 2 and negative 2. And we get 400 is equal to a. So our final function is f of n equals 400 times negative 1/2 to the n. And remember, you always check your work. So let's try 4. If I plug in 4, I should get 25. Right? So a half to the fourth is a half, negative a half, rather negative a half to the fourth. Negative a half, negative a half, negative a half, negative a half. So negative a half times negative a half, that's positive 1/4. Positive 1/4 times negative a half, that's negative 1/8. Negative 1/8 times negative 1/2, that's positive 1/16. So it's 400 times 1/16, and that is 25. And 25 is exactly what we get. Okay, for the recursive, remember we start with f of 1, what that is. And then for every other term, we go back to the previous term and we multiply by negative a half. Okay, so hopefully you found this video to be helpful. Again, this was an update of the video due to the fact that someone did point out that I had made a mistake. I'd actually said a quarter. And I don't know what I was thinking there. I meant to say a half. So, or rather negative a half. So please make sure you understand what happened here. I'll make sure I reach out with the update so that everyone knows the answers and that they're there. But have a wonderful day. Don't forget to love math. And remember, everyone, don't forget, you can do it. Thanks for watching, and I'll see you next time.